This is a LeetCode Biweekly Contest 124 live stream. If you are looking for solutions, skip ahead 90 minutes to after the contest ends. We don't hand out solutions during the contest, but we answer questions on the live chat and give hints. So code along with me in Contest 124. This is Alex Does LeetCode. Like and subscribe. Alright, welcome to the chat. Remember, there are no solutions given during the contest, but if you ask questions in chat, I'll try my best to answer them. And I can clarify what the question means. And I can also give hints. Hi Rohan, welcome back. Good to see you again. Good luck for the contests. Welcome, folks. Welcome to the chat. There's people are starting early today. Remember, we don't share code in this channel, but if you have questions, post them in the chat. I'll try to give you hints. I'll try to answer any sort of clarification questions that you have. And yeah, someone else might give you will give you hints too. So stick around. I don't talk much during the contest itself because I have to focus on getting work done. But let's all work on the contest together and compare notes at the end. Hi, Rohan. You have a question in chat. Can you tell how to delete front elements in Vector? That depends on what programming language. Are you talking about Java? Are you talking about Java? I don't know offhand, but I'll give you a hint. So for question 1, you don't actually have to delete anything. Right? If you think about it, you just need to count how many times. Let me see. You just need to count how many times you do this. You don't actually C++. You don't actually have to delete anything. If you delete things in C++ and Java in a vector, it's going to be slow. So you don't have to delete anything. You just have to remember how many times you do it. So think about the example that they give, right? They have 3, 2, 1, 4, 5. You look at the first 2 elements, and then you look at the third and fourth element, and then you look at the fifth and sixth element. You don't actually have to delete them. You just look at the element and see, can I do these guys have the same score or not? Does that make sense? So look at the first 2 elements. What is the sum? And then you next look at the next 2 elements. Do you see do they have the same sum? If yes, then you keep going. If no, then you stop. Then you look at the next 2 elements. Do they have the same sum? And you keep repeating. So you don't actually have to delete anything, right? If you think about it. Okay, coding IT. You want a hint for question number 2? Let me see. So question number 2, for every alphabet A to Z, remove the first occurrence of the letter in S. Yeah, this one you actually have to delete something. So this one is going to be language specific. So Shivam, I'm not at number 3 yet, so you're faster than me. Let me finish up number 2 real quick and get to you. Number 3 is harder than I thought it would be. Let me see. Interesting. Welcome. There are more people in the chat now. Hope you guys are having a good time with the contest. This week seems, to me at least, a little bit harder than usual. But maybe you'll have a better time than I would. Hi Shivam, I'm unsure what the state should be in question 3. What do you mean by state? Are you trying to use some kind of dynamic programming solution? If you're thinking of what kind of I'm gonna guess. I'm gonna have to guess a little bit to what you mean. If by states you mean some kind of dynamic programming solution, then your state will be the 2 pointers. Because you think about your array, right, or your vector, as you delete things from the left side, you move the left pointer. And then you delete things from the right side, you move the right pointer. So again, you don't actually have to delete things at all. You just have to keep the left and right pointer. And as you quote unquote pretend delete them, you move them towards the middle. I hope that's helpful. If that's not helpful, ask again. So I'm not quite sure what you mean by states, but if that's not what you meant, then ask again. I'll try to help. But I'm also working on question 3 myself, so take that with a pinch of salt. This week suddenly feels more difficult than the usual. Definitely feels a bit more difficult. Or maybe it's just me. Welcome to the chat. I see more people in the chat. Again, as a reminder, solutions are not given during the contest, but if you have questions, feel free to ask in the chat. I'll try my best to answer. I don't have all the answers for you, unfortunately, but I'll try my best to answer, and we'll talk about it after the contest ends. That will be in another 1 hour. Hi, hello. Let me take a look at the chat. Hi, Summer Jane. I'm good. I'm still working on question 3. Trying to get it in quickly. This contest is pretty difficult. Let me see if I can answer some questions. Shivam Kushwa, I'm unsure what the states should be in question 3. Okay, so AEIOU. I'm trying to do third by recursion. Should I change my approach? I'm not sure, to be honest. I don't think I strongly suspect recursion would not work because of how many states you have to recurse through. Yeah, you can try it with recursion. I actually just jumped to the dynamic programming version. So dynamic programming is a very common way of fixing these kind of things because you think about recursion, right? You have to test like a lot of different combinations. I don't think that will work, but you can try it. Dynamic programming is just recursion plus, a memorization table. So Varun Agrawal needs some help on second question. Let me see if I can get to them one by one. Second question. Damn it. Apply operation to make string empty. Let me see. Yeah, so for Varun, for second question, you don't actually have to delete anything. So you think about it, right? You want to count how many times you can delete items while the total is the same. So first step is work out what is the total. What is the first 2 items added up together? Oh, sorry. Am I talking about the same question? Apply operations to make string empty. First occurrence. Oh, okay. So, question 2, you actually have to delete stuff. So basically what you want to do is first delete the first occurrence of all letters from A to Z. So just do that. And then you keep doing that until you delete everything. Yeah? So, yeah. So I think that's all there is to it, honestly. So every step, delete every single letter from A to Z once, which is delete the first occurrence of every letter from A to Z, and keep going until you reach an empty string. And then you keep a previous variable, right? A pref variable that keeps track of what it was just before you reach that empty string. Keep doing that until you reach the end. There's a slightly fancier method of doing this, which is you count how many times each letter occur. And then you find the letters that occur the most number of times. They are the ones who will survive till the end. So the other way is to have some kind of frequency table. So that's the slightly faster way of doing it. Yeah, I hope that's helpful. So Akshit Yadav, help with the first question. So I'm gonna ask you not to post any code here, but just don't post any code here, because if you post code, somebody copies your code, then that's considered cheating by LeetCode, and your account will get suspended. Let me just take a look. First 2 elements of numbers and delete them. Yep. So map put. I don't think you need a map. Oh, no worries. Yeah. Yeah. No worries at all. I should stick it somewhere. So for this, I don't think you need the map at all. So first step is you figure out the first 2 numbers, right? The sum of first 2 numbers. And after you figure out the sum of the first 2 numbers, then you go through then you start the for loop. Yeah, so first you do the sum first. You get the first two numbers, add them up, and then you do a for loop that checks. Does that make sense? Yeah, I hope that's helpful. So Rashish Jain, do we have to use Q? Which one are you talking about? If you question one, you don't have to do anything. It's quite straightforward. Yeah. But we'll talk about it. If you get stuck, don't worry. We'll talk about it at the end. Solved it by using Q. I'm curious So Pushka and Rashi, which question are you guys talking about? I didn't use Q in any of my questions. Hey, stuck in 3? Yeah, I'm also working on 3. So suggest any approach for the second one. So for the second one, you're basically, you're deleting things. So one way you can do it is just delete them. Yeah, just delete every round, delete the first occurrence of every letter from the alphabet that you can find. And then after you do that, and at the same time you keep like a pre-string to check. You keep a pre-string to check what is the second last occurrence of this. The other way you can do it is to just think about. So this is for question 2, right? So in question 2, you think about what is the second last string that you get. Well, the second last string you get contains, it's just because before you make everything empty, right? So it contains the letters that occur the most number of times. Correct? So if A appears 10 times, B appears 10 times, C occurs 9 times, the last string, you'll keep deleting, right? After 9 operations, all the C's will be gone. You'll be left with A's and B's only. And if you delete those two, then it's empty, right? So the very last string will only contain occurrences of A and B. If A and B occurs 10 times, C occurs 9 times, D occurs 5 times, it'll only contain occurrences of the letters that occur the most number of times. Does that make sense? So you can use that as a hint. Use some kind of frequency table. So I hope that was helpful. I don't want to give away the whole solution, but I will tell you the answer. We will go over the answers at the end. So let me see. Suggest second question. Yeah. So Lucid Dreamer also has a hint for you. So thanks, Lucid Dreamer. That's a great hint because you didn't post any code. So people still have to work on it on their own, and it doesn't violate LeetCode's contest policies, so none of us get into trouble. So thank you, Lucid Dreamer. Coding IT, brother, how to get to solve 3? I'm still working on 3. Delete one paired account total. Sonu Lambda with Sonu Lambda. Which question are you talking about? 3 cases, like maybe first 2, first plus last. Yep, contain both as different cases. Yeah, that's a great question. I actually consider both as separate cases because the ending might be different. There might be some situations where, you can delete from the left, you can delete from the right, right? So there are some cases where you delete from the left, you would actually get to the answer, and delete to the right, you won't get the answer, where the expected answer is wrong. Yeah. Yeah. So you delete from the left, delete from the right. Sometimes you get different cases. Okay, so I have to go back to working on mine because I'm still stuck. Yeah, I'm also stuck on question 3. I'm still working on it. So, my strategy is to use dynamic programming with 2 pointers. So there's a left pointer, right pointer, and make that dynamic programming. Turn that into a dynamic programming problem. There might be an easier way to do this. I'm not sure. Hi, Dipanshu. I actually don't understand Hindi, so I can only speak English. It runs correctly, but give TLE on submission. Yeah. I also got TLE in yes, I also got the TLE. I use dynamic time limit exceeded. Yes, I also got. Yeah, well, so I also did 2 pointer. So I'm trying to rewrite. So did you guys use like So I just use a memorization table like a dictionary. Did you guys use an array or dictionary? So not a dictionary. I did a list. I did a list, a memorization of table of all the pairs of left and right I've seen. So that one doesn't work. That one is TLE. So I'm trying to rewrite now as a 2-dimensional array. So one dimension is the left, one dimension is the right, and then you fill in the array. Because the length of the input is only 2,000, so a 2-dimensional array is only 4 million items is doable. Yeah. So I'm trying to do that. I don't know if I can get it within the time limit. Yeah. But now I'm actually going to take a stab at question 4. Well, Aniket, I guessed because I know most of you are from India. Also, I know bye means bro, and you guys like to use the word bro. I think bye means bro, right? A DP you will not attempt? Oh no, I think most questions have a lot of questions need some kind of DP. I'm pretty sure Q3 is DP. I tried, I tried one DP and it doesn't work. I'm trying like a different version. I'm actually moved on to question 4 because I had to answer some questions, right? So I had to change my brain. So I answered all yours questions about 1 and 2. And so I forgot what I was doing on question 3. So I'm going to question 4, giving it a shot. Maybe I'll be lucky with question 4. Who knows? Oh, very nice. Rate finance. Great job. Just use recursion with memoization. That's what I did. I did recursion with memoization hash map. How come it doesn't work for me? What language are you using? I'm using Python. I don't know whether it's because Python is a bit slower. Or maybe I made a... Yeah, that's exactly what I did. Python as well. Okay, you know what? You're a better person than me. Rate finance. Great job. Congratulations. I'm working on question 4. If I manage to do it, I'll go back to question 3. Hmm. Damn. I did the same thing as you, Rate Finance. Maybe it's the way I wrote it. Maybe it's the way I wrote it that's not doing it right. Yeah, thanks for giving hints in the chat, Rate Finance. Really appreciate it. Also, congratulations on solving Q3. I'm still working on Q4. If I can get it done, I'll go back to Q3. Any hints for question 4? So for question 4, yeah, I'm still working on it. The way I'm doing it is, basically there's this idea that you sort of like, you see a 2, you see another 2, the second 2 can become a 3, right? And then if there's a 3, the second 2 becomes a 3, the other 3 can become a 4. So there's this idea of like pushing extra things forward. Does that make sense? So if you have something, you can actually push it one forward. So the way I did it is, basically start by sorting. So if you start by sorting it, well, I'm still working on it, but if you my strategy, if you start by sorting it and then you see, okay, how many ones do I have? I have like 5 ones, right? So I can push 4 of them. I can, push one of them forward to the 2, and then see how many 2s do I have. If I have now 2 2s, I can push one of them forward to a 3. Because I'll increase one of the 1s to 2, the 1 of the 2s to 3, and then so on and so forth. And I'll keep like sort of quote unquote pushing forward. I want to see if I have like extra stuff to push. I hope that helps. Okay, 7 more minutes. I don't think I can finish question 4. I'm going to see if I can finish question 4 within the time limit. Question 4 is not as hard as the usual question 4s, I think. Alright. I think the can test is over. It's going to be over soon. I can't finish question 4. But I feel like I'm pretty close. Let me just do the discussion anyway. Then what I'll do is I might try to finish question 4 on stream while like coding it on stream. If you guys are interested. But I'll go through the answers. Man, this was not a good contest for me, but it sounds like it's better for you guys. It's a little bit better for you guys. I'm done, but I'm still getting... Okay, give me a 1-minute break. I'm going to drink some water, and I'll be right back. DP contests are the worst for you. Well, Red Finance, you did finish question 3 before any of us. So, great job there and congratulations. Alright. This is LeetCode Biweekly Contest 124 live stream. We are discussing answers right now. Now, this contest was pretty rough for me, I'm not gonna lie. I only managed to finish question 1 and 2. Question 3, I took a lot of time. I feel like I was stuck by some kind of mistake. Red Finance in my chat got it right before any of us. And question 4, I think it's not hard. I didn't manage to finish question 4 within the time limit, but I want to do question 4 live on stream immediately after this answer discussion. So hang out, stay tuned if that's something that you're interested in, if you haven't solved question 4 yet. And now let's get into it. But before that, remember, if you like and if you enjoy my content, please like and subscribe to my channel. It helps us out a lot, and you also get notified every week when we push new content. So let's get into it. So we're going to start with question 1. Maximum number of operations with the same score. So in this question, what you do is you're given an array of integers called nums. You want to perform the following operation while nums contains at least two elements. So choose the first 2 elements of nums and delete them. And then the score is the sum of the deleted elements. Your task is to find the maximum number of operations that can be performed such that all operations have the same score. return the maximum number of operations performed that satisfy the condition above. Okay, so let's go to an example real quick. So for instance, for this, the first two elements is 3 and 2. So if you delete them, your score will be 5. Score will be 5. So with this score of 5, what you do is you go on to all the other elements and you just check. If the next pair is the score 5, well, you can delete them. And then you're basically deleting it twice. And then, so you can basically do it twice. You can do it to 3 and 2 and 1 and 4. Because they both give the score of 5. Okay? The main thing is to note is that the score depends on the first two elements. The sum of the first two elements sets the score. So you always have at least one deletion possible. You can delete the first two guys. So same thing here. So the first two elements is 3 and 2. The score is 5. Well, the next two elements is 6 and 1. That's not going to work. So that's wrong. So we can only perform the operation once. So that's what we're going to do. So essentially our solution is pretty much the same as our logic. Right? We start with a count. We find the score. I call it total, but it's also like score. Same thing. Score is 0 and 1. And then in range, I just check if the next two, the score, sum of the next two things is equal to score. And then I do count equals count plus 1. Now note that you don't actually end up deleting anything from the array. You just essentially move a pointer, right? Here I have this pointer I. That tells me what my next guy is. So I move it 2 steps at a time along down the array. I don't actually delete anything from the array. Okay. So that's it for question 1. I think most people got it. So question 2. So question 2, you are given a string S. Consider performing the following operations until S becomes empty. For every alphabet character A to Z, remove the first occurrence of that character in S, if it exists, and then you keep doing that. So essentially what you want to do is, I want to zoom in a little bit on here, because it took me a while before I understood what this question is talking about. So basically what you want to do is to delete things. Let's use this to delete. So step 1, let's say you're given this, right? You delete A, B, C. Okay? And then you delete A, B, and C. And you keep deleting. So essentially what you're doing is, at every point you delete the first occurrence of every letter in the alphabet. There's only A, B, and C here, so I only delete A, B, and C. Until you get to here, and then you delete B, A, B, and C. And then you're empty, right? At some point you delete things until they're empty. Now, what you need to return is the state just before the last deletion. So here, I've carried out 2 deletions. After 2 deletions, after 2 deletions, come back to here. 2 deletions, after that, you get B and A. Right? After 2 deletions, you get BA. So this is the guy you're supposed to return, just before reaching the empty string. So there are a few ways of doing this. The first way to do this is a naive solution, which I think also works. You do exactly what you say, right? You start with a previous pointer to remember what is the last guy you do. And then at every round, this while loop keeps going, and while the length of S is larger than 0. At every round, what you do is you go through A to Z, and then you delete the first occurrence. So this part is actually language specific. I will not go through the details, but essentially it iterates from A to Z. In Python, it iterates to A and Z. I use char and odd as a way to do the iteration in the same way. I find the first occurrence of this guy, and then I find the first occurrence of this guy and I delete it. And then if length of S is larger than 0, then I set pref. If not, pref will always be equal to the guy just before, and I return pref. So this one I think works, but there's an even better solution, which is the one that I'm going to go through right now. and it looks something like this. Okay, I'm gonna explain intuition. So the slightly better solution is the following. So think about deletion, right? If there are, let's say in this, there are 1, 2, 3, 3 A's, there are 3 B's, there are 2 C's, and let's say these, there's only 1, right? One occurrence of these, right? So what will happen when you delete once? Well, the D will be gone. We delete twice, the C will be gone. If you delete 3 times, the B and A will also be gone. So just before everything will be gone. So just before everything is gone, the only letters that are left are the ones that occur the most number of times. Does that make sense? So if A and B occur 3 times in this solution, right? If A and B occur 3 times each in this solution, then after deleting twice, only A and B will remain. And there'll be 1 B somewhere and 1 A somewhere. And everything else will be gone. So essentially what we can change our approach is to use a frequency table. So this is what I did for a frequency table. The first step is to calculate the frequency table. You've done this a million times, right? You go through the characters in S, you add them to a frequency table. Then next step is to find the frequency that occurs the most. So most, yeah, you just iterate through a frequency table. And then what I did is I found the characters that occurred the most. If freq C equals to most, then occur C equals to R find C. So if essentially I'm finding the last occurrence of that letter. I'm finding the last occurrence of A and the last occurrence of B. Why do I need the last occurrence? Because I know there's 1 A and 1 B in the solution. I need to know if it's A, B or B, A. So I find the last occurrence. In this case, the last occurrence of A is here. The last occurrence is B is here. So I know it's BA. So after that, I do some, like this is all Python magic. You don't have to know it exactly, but the intuition is more or less the same, whatever language you use. You just find what is the last occurrence of the letter and then sort them by last character, last occurrence, and then join them together. So this will get you the answer. Okay. All right. Red Finance, you posted a lot of interesting code here. This is kind of hard to read. Actually, I wonder if you can, actually you share your answers. You know what you can do if you want? You can post them onto, since the contest is over, you can actually go to discuss. Yeah, you can post them on discuss. If you want, Red Finance. You want to share your code. I'm actually interested in what your code is because I tried, basically I think the same thing as you and I didn't manage to get it. Okay. So on to question number 3. Question 3. So given an array of integer nums, you can perform any of the following operations while nums contain at least 2 elements. 1, you can choose the first 2 elements of nums and delete them. 2, you can choose the last 2 elements and delete them. And 3, you can choose the first and the last 1 element each and delete them. The score is the sum of the deleted elements. Your task is to find the maximum number of operations that can be performed, such that all operations have the same score. So this is very similar to the first question, but you don't just, in the first question you can only delete from the front. Now you can delete from the front, you can delete from the back, or you can delete 1 from the front and 1 from the back. So like half. Okay? So this makes it a little bit trickier, and it actually makes it a lot harder. Because you think about it this way, if you look at this example, for instance, if you delete from the front, you can get 3 and 2. Okay, that will give you a score of 5. And then next, you can delete this 1 and this 4. That works too. Right? And then you delete the 2 and 3. So you're essentially deleting First round, second round, and then third round. So this makes it a little bit trickier because you have more options, okay? You have more options. So you can, there's actually like a naive way of solving this using recursion. Okay, let me just get rid of my stuff first. So there's a naive way of solving this using recursion, which is basically you keep a left pointer. So just like question 1, you don't actually have to delete anything. Remember question 1, we didn't delete anything, we just keep a pointer, we keep moving the pointer to the right, right? So now, because you have to you have to sort of remove stuff from both ends, you have to keep 2 pointers. You have to keep a left pointer and a right pointer. So when you delete, let's say, this red one, you're going to move the left pointer from, from here to here. And then you check, can you still delete this? Yeah. And then you keep going, right? So every one time there are 3 possible options. So the tricky part is that not all the 3 options are not all equal. So let's say for instance is 3, 2, 1, 4, 3, 4. I think so. I'm going to think. I don't think all the options are equally viable. So it's possible for you to get stuck. Yeah, I have to construct a example. But I don't think it's possible. I think it's possible for you to get stuck. I'm not sure. So basically, if there are 2 possible options, you have to consider both. So your branching factor becomes pretty big after a while. Or maybe you don't get stuck. I have to try it out. Yeah, so your branching factor becomes really big. So the naive way is to use some kind of recursion. So a better way is you actually need a dynamic programming solution. So you basically write the recursion and you add a memorization table. I unfortunately got stuck here. I tried that and then it didn't work. And I tried this other version, which I did like basically I did like an 2-dimensional array. A 2-dimensional array will keep track of pointers. Yeah, but I didn't manage to finish this. I'll try to finish it in a bit after I finish talking about all 4 questions. And then I'll see whether I can get a better version of this answer in a bit. Okay. Let me see what's going on in the chat. I've definitely not implemented good coding practices. It's a contest, yeah. The reason for so many is condition overlap indices. Yeah, Red Finance, I'll take a look. I'll try to copy and paste your code somewhere and take a look at it later. Okay, so on to question 4. Yeah, because I actually want to finish question 4. I think it's not that hard. I want to see if I can finish question 4 after the contest in the next 30 to 45 minutes. I have some time before I need to close the stream. So the question 4, which thankfully I think is one of the easier question 4s in the past few weeks. Oh my god. Last few weeks, the question 4 is like 8 points. I don't know. It's crazy. Okay, question 4. You're given a 0-index array nums consisting of positive integers. Initially, you can increase the value of any integer by at most 1. After that, you need to select 1 or more elements from the final array, such that the elements are consecutive when sorted in increasing order. This is very complicated. But let's look at the example. So the example is here. You have 215111. And so what you want to do is to form sequences, right? You want to form like 1, 2, 3, 3, 4, 5, 5, 6, 7. You want to form the longest sequence that you can. You want to form the longest sequence you can. So essentially what you need to do, you can form the longest sequence you can, but the catch is you can actually you can add 1 to a previous number if you're missing something. So for instance, here you have 2, 1, 5, 1, 1. You don't have a 3, right? You can add 1 to a 1 to turn it into a 2, and then 1 to the 3 to turn it into a 3. And this will give you 1, 2, and 3 to form your sequence. Right. So this illustrates basically the principle that I want to use, which is there's this idea of like pushing, right? So you have 3 1s, I can push one of them to become a 2. Now I have 2 2s, I can push one of them to become a 3. Right? So I'm basically like pushing something to the next item. And then if I'm missing an item, I can sort of push a number to sort of make up for the gap. Okay, so my strategy is the following. First, I sort my strategy. I'm still writing it. I'm going to actually finish it up right after this answer discussion. If you want to hang out and look at it, it's up to you. So first, I sort this 1 1 2 5, right? So what I want to do is I want to just go and I want to say if I see a 1, if the next number is a 2, if the next number is a 1, that means I can push. I have a push. I can push, right? This means I have more than 1 1, I can push it to the next one. So I see a 2, right? 1 and 2 is consecutive. Okay? If my next number is consecutive, it means that I'm good. I keep going. So now my next number is 5. 5 breaks the streak. So I'm going to see, hey, if I can push this 3. And this will give me 1, 2, and 3 for a streak of 3. Okay? So what about another one? 1, 1, 1, 2, 4, 5. Okay? So 1, I see a duplicate, I can push. I keep going, I can still push. So 2, right? There's no 3. So I can't push anyway. I can push here. I can inject the 3. No more push. So 4, good. 5, good. And then I'm stuck. There's no 6 and I don't have an extra item to push. So the idea is the following. You want to keep like a sequence, right? You want to sort them and then you want to keep like a sequence. You want to keep going up. You want to see if the next number completes your sequence or not. If the next number is a duplicate, you get this extra like thing that you can push later on. If it's not, then well, too bad, right? You keep going. If it's not in sequence and you don't have a push, then you sort of break, right? That's what's happening here. You break. Because you don't have an extra number, you can't get to 7. Okay? So that's the basic idea. So the basic idea is actually, I think if this works, then you don't need DP or you don't need anything clever. You just need to sort them and then keep going, find the longer sequence, and keep track of whether you have an extra element, extra number to push or not. Oh God, I'm so sorry. Oh shucks. The screen is frozen? Oh my God, I'm sorry. My screen is it? Hold on. By the way, my screen has been frozen for 5 minutes. I'm so sorry. Which question was it frozen on? Okay, I'm gonna assume it's question 4 that is frozen on. Sorry, let me read the chat real quick. I'm sorry, guys. on the first problem, yeah, sorry about that. Okay, let me go over question 3 again then. Let me go over question 3 again. All right. So sorry about that. Yeah. So sorry about that. So let me go over question 3 and 4 again real quick. I'm sorry about that. I didn't realize that because I have 2 windows, I forget which one I'm sharing. So this is question 3. So the difference between question 3 and question 1 is that instead of always deleting the first 2 elements, you can choose also the last 2 elements or the first and last element. So that's the difference between question 3 and question 1. This, however, makes it really tricky, and we'll see how it works out in practice. So for instance, for this 3, 2, 1, 2, 3, 4, the first thing we want to do is, let's say we start from the left. Our score will be 2 and 3, which is 5. The second round, we can delete 1 and 4. We don't have to select 1 and 2. We have to check all 3, right? Front and back. Front and back adds to 5. So that's eligible for deletion also. And then 2 and 3, that adds to 5 also. So that's also eligible for deletion. So the point I'm saying is that it's different from question 1 in that you can delete from front, back, or middle. Okay? So the one thing that it is similar with question 1 is that in both questions, you don't actually have to delete anything. So in question 1, remember there was a pointer, right, that moves from the left to the right. In question 3, the pointer is both in the front and back. So the pointer starts here and here at the beginning. And then as you delete the first 2 items, the pointer moves to here and here, right? So you don't actually have to physically delete from the array. You just keep track of the pointer and keep shrinking them towards each other. Okay? So it's pointer and here. And basically, you can think of this, there's a recursive method, which is you check all 3 possibilities. Delete from the front, delete from the back, delete from front and back. And then you sort of like keep going. Now, the unfortunate thing about this is that you actually run into a problem with the memoization. Yeah, we run the problem with like the combination. The combination is very large. So what you need to do is to use some kind of memo table to store which combinations you've already seen. So, for instance, I get to this point. There are many ways to get to this point. And the memoization will help me keep track of all the ways I've get to this point. So the state of the memoization table is basically your left pointer and your right pointer. I tried doing this. I'm kind of paranoid about my screen being frozen. Yeah, I tried doing this initially using dp left, dp right. I tried doing this using a list or hash map. It didn't work, which was annoying. Then I switched to an array. I didn't manage to finish in time. I'm going to try again with the list, because apparently somebody in the chat managed to do it in Python with like a set or hash table. Okay, so question 4 again, because I messed up my screen the last time. But thanks folks for sticking around. So question 4, I think is one of the easier question 4s I've seen in a few weeks. It's also one of the more interesting ones. If you've not tried it, I definitely recommend that you do try it. I didn't manage to finish it in time, but I am going to try and attempt to finish it within the next 30 minutes live on stream right now, and see how far I get. Feel free to try it out with me. So question 4 is the following. You are given an array nums consisting of positive integers. You can increase the value of any element in the array by at most 1. You can increase any of them by 1. Okay? or none of them. It's up to you. Okay, and after that, you need to find sequences. Find consecutive sequences. One or more elements from a final array such that those elements are consecutive. Like 3, 4, 5, 1, 2, 3, etc. So take for instance this one. 2, 1, 5, 1, 1. Okay? So what you do is you take this, you increase 0 and 3. So you get 3, 1, 5, 2, 1. Right? 3, 1, 5, 2, 1. You increase 2 to 3, 1 to 2. This gives you 1, 2, and 3. Choose a different color. That gives you 1, 2, and 3, which is a sequence of length 3. So the answer is 3. Length 3 sequence. Yep. This example, you notice right away that all of them are more than one item apart. So even if I increase 1 to 2, it cannot form a sequence with anybody else. You increase from 4 to 5. 5, there's no 6. You cannot connect to 7, right? So all these numbers are very far apart. So, you cannot form a sequence with any of them. Okay, so how do you do this problem? Well, I don't think it's that difficult a problem. So my strategy, I'm still working on it, is to start by sorting. So I have 1, 1, 2, 5, 1, 1, right? I'm going to sort it first to get 1, 1, 1, 2, 5. And then what I'm going to do is the idea that I'm going to keep in back of my head whether I have an extra element that I can push. So, make sure my screen is on. So 1, it is the first one I saw, so no push. I see a 1, so I can push. I can still push because it's still a 1. 2, I can still push because 2 is a sequence of 1. I don't need to use my bonus push, right? And now there's no 3, so I'm going to use my push to add a 3. I'm going to use my push to add a 3. Okay? And then now, I get to 5. Well, I have no more push anymore. So when I see 5, I'm stuck. My sequence will be 1, 2, and 3. So let's say, if this is 1, 1, 2, 4, 5, 7, what will happen is, I get to 2, I have no push, right? I'm going to use my push to jump all the way to 4. Because I can sort of like push the 3, use a push on the 3 to jump all the way to 4. And then I keep going, 4, 5, still no push. And then now I'm missing a 6, right? I can't jump because I don't have a push anymore. So the sequence ends here. So the sequence is 1, 2, 3, 4, 5. Yep. So that's how I'm going to do it, essentially. If I, for instance, had 4, 5, 5, 7, then I have no push here. I have no push here. I get a push here because I have duplicate 5. And that allows me to jump 1 to 7. And then my sequence will be 1, 2, 3, 4, 5, 6, 7. Yep. So that's going to be the strategy. That's going to be a strategy. Step 1 is to sort. Step 2 is to keep track of whether I have like an extra element to push to jump to the next one. And essentially use that to find the longest sequence. Yeah. So let's work on that. I'm going to work on that right now live, and hopefully it's going to work. If it doesn't work, then, well, that's too bad. Yeah, let's see if this works. Thanks, by the way, everybody, for tuning in. I am just trying to finish up question 4. The contest is over, but I'm pretty sure I can get question 4. I just want to finish it up for my own vanity. Okay. Let's see if this works. Wrong answer. Huh. 8, 9, 10, 11, 12, 13. Eight, 9, 10, 11, 12, 13, 14. How can it be 14? Yeah. Why is it 8? Huh, interesting. Oh, the 6 can become a 7. Interesting. Ah, dang it. Alright, let's see if this works. So 2, 7, 8, 10, 11, 12, 12, 18. So 10, 11, 12. Oh, interesting. Okay, interesting. So 10, 11, 12. We will strict here. This 12 can become 13. Oh, nope. This is not correct. So this should be 4. Hey, for folks who just joined the chat, the contest is over. I'm just finishing up on question 4 because I didn't manage to finish it during the contest, but I'm pretty sure I got it right. I'm pretty sure I'm very close to it. I'm very close. I think I'm very close. Yeah. Let's see. I think there's one more special case I need to take care of. Yeah. Yeah, I don't think it's that easy. Now that I think about it, I got really close. I mean, I got really, really close. So essentially what I managed to do is I identified that this 10, 11, 12, 13 is a sequence. This can become 13. But I need to identify that 7 and 8 can become 8 and 9. How do I identify that 7 and 8 can become 8 and 9? Yeah. How does that work? Yeah, 7 and 8 can become 8 and 9. That is a bit harder. Yeah. So one thing I can do is to just check like backwards. But this is tricky. This 7 and 8 is actually tricky. Because there are cases like 6, 8, 10, 11, 12. So this 8 can become a 9, but the 6 cannot become an yeah. Let me see. So these guys don't have like ability to push, right? Maybe it's not that hard. So 8 can become a 9, okay? 6 cannot become a 7. Because 6 needs to become an 8. That's not possible. The 8 has to become a 9. 6 cannot become an 8. Okay. Let me see if this works. I'll try one last thing. Okay. Alright. Let's see if this works now. Maybe it does. Cross your fingers. That's all any of us can do at this moment. Oh, the last one.